Okay, it's 8 a.m., the coffee's brewing, the news feed is scrolling, but before you've even cleared your inbox, AI is already redefining what's possible everywhere.
It really is. Just think.
Imagine a hospital lab robot autonomously designing a new drug compound, right? Identifying promising candidates before the sun's even fully up.
And at that exact same moment, somewhere else, maybe an open source AI model is acting like a digital guardian.
Yeah, defending a major network from some sophisticated deepfake attack engineered by, well, who knows, maybe another AI.
Could be. Meanwhile, you've got regulators in government buildings trying to figure out how to even define these systems. They're changing so fast.
Well, across town in boardrooms, corporations are looking at their massive AI investments and saying, okay, where's the cash return?
It's this incredible mix of revolution happening right now, all around us, and yeah, the speed is just breathtaking.
It really is. A landscape buzzing with, unprecedented innovation, absolutely, but also thick with really big questions and power dynamics shifting under our feet.
The pace feels exponential, doesn't it?
It absolutely does. And that brings us right to the core question we want to wrestle with today in this deep dive into AI, here in mid-2025.
Okay.
In this whirlwind with systems doing things we literally only dreamed of a few years back, are we actually steering this thing? Are we making deliberate, informed choices about where it's all going?
Or we just kind of swept along,
Yeah.
reacting to forces that feel more and more complex, maybe even a little bit out of our control.
That's the tension, right? The tech itself just keeps advancing relentlessly.
Right.
But the forces shaping how it gets used, how it gets adopted, its real impact. Well, that's this complicated mix of economics, global politics, and policy that's forming as we speak.
Exactly.
And that's our mission today. We've gathered a whole stack of sources, the latest research, industry reports, news articles to try and cut through the noise, get a clear picture of where AI really stands right now, middle of 2025. We're going to unpack the big macro forces shaping things, look at the competitive map, who's winning, who's under pressure. We'll explore the absolute cutting edge of the tech itself, see how it's shaking up whole industries like healthcare.
And talk about talent, investment, what it all means.
Exactly. The goal is to help you understand what's critical right now, grasp maybe some surprising facts, and hopefully feel a bit more grounded, maybe more empowered, navigating this incredibly dynamic world.
Sounds good. Let's dive in. There's a lot to cover. And like you said, things are moving fast.
Okay, let's start with that big picture then. The macro trends fundamentally shaping this mid-2025 AI landscape. And the first one, it's hitting everyone, from the smallest startup to the biggest Fortune 500s. It's a demand for return on investment, real, tangible ROI.
Oh, absolutely central. That initial, wave of excitement, the novelty factor around generative AI, that's definitely settled down.
Yeah, the honeymoon's over.
Right? Companies aren't just playing around anymore or buying AI because it's, well, the cool new thing. They've poured serious money in over the last couple of years.
Serious money.
And now they're looking really hard for results they can measure. This phase is pragmatic, intensely enterprise-focused.
It is totally a show me the money moment for AI. Businesses are the main customers now, and they're not just asking for neat features. They want optimized performance. They want verifiable profitability. They want robust security.
And those big AI budget requests, they're not getting rubber stamped anymore just because AI is cutting edge. They face intense scrutiny.
You need a clear business case. You need to show exactly how this AI tool is going to cut costs or boost revenue or seriously improve productivity.
Right.
Demonstrably.
And that focus, that intense focus on ROI, it's directly tied to this other big theme, AI efficiency.
Right, because these big models,
they take huge amounts of compute power, right? Often running in these massive data centers. Yeah. And that means high running costs, significant energy use.
Not trivial at all.
So companies now have to really carefully balance those operational costs against, their sustainability goals, which are becoming more important. And of course, the actual business benefits they expect to get from deploying AI at scale.
So efficiency isn't just like a model getting a slightly better score on some benchmark test anymore.
Not at all. It's about the total cost of ownership. TCO. How much does it actually cost to run this system reliably, day in, day out, at the scale you need? And what's its environmental impact at economic reality? It's maybe the single biggest thing shaping AI development right now.
And you see it directly pushing innovation towards smaller, more efficient models.
Absolutely. It's a clear trend, and
Yeah.
it's accelerating. These more compact AI models aren't just getting better and better performance-wise, sometimes matching much bigger models from just a year or two ago, but they're also way cheaper to run.
Which makes them way more attractive to businesses staring hard at that bottom line, right? Especially if they want to deploy AI across lots of different parts of the company.
Exactly. That corporate push for real returns isn't just speeding up the development of these smaller, powerful models. It's also driving demand for specialized hardware, things like ASICs.
Application-specific integrated circuits.
Right. Chips, custom designed for specific AI tasks. They can be dramatically more power efficient for those jobs than general-purpose chips.
And it also makes those powerful open source models, which often have a reputation for being cheaper to run than calling a proprietary API.
Much more appealing, especially for internal use cases or tasks where you need deep customization.
So let's translate this. What does it mean for you listening if you're involved in business strategy or buying tech or really any decision-making role?
AI has firmly moved out of the cool tech demo phase and into the serious capital expenditures category. It's an operational cost, and it needs to show a clear, quantifiable payoff.
That changes the whole conversation. It's not, can we use AI anymore? It's, okay, how will this specific AI solution, this stack, deliver measurable business value, optimize our operations, and ultimately give us a competitive edge? That focus on value is reshaping everything. Sales cycles, internal roadmaps, everything.
Huge shift.
Okay, shifting gears a bit from the bottom line. The next major force reshaping the global AI scene is intense geopolitical competition.
Yeah, this is big. Nations around the world are increasingly looking at AI not just as, a technology, but as a critical national asset, almost like oil or strategic minerals in the past.
And this competition is fierce, maybe nowhere more obvious than between the US and China.
Absolutely. AI isn't just for researchers or businesses anymore. It's core to international relations, national security, economic clout, even how global rules get made.
It influences everything. Major trade policies, like those US export controls on advanced chips, trying to limit China's access to the hardware needed for cutting-edge AI.
Right. It affects investment flows, diplomatic ties,
Yeah.
and critically, it's fueling this idea of sovereign AI.
Sovereign AI. Let's unpack that.
It's become a really prominent theme. Basically, it refers to efforts by nations or sometimes regional blocs to build and control their own AI infrastructure.
Their own compute power, their own data centers.
Their own foundational models, often trained on their own national data. The goal is to protect national interests, ensure they control their data, and stay technologically competitive. It's about having direct control because this tech is seen as just fundamental to future power.
If you look at the investment numbers from recent reports, the U.S. is way out front in private AI investment, something like $109 billion in 2024.
Which is huge. It dwarfs China's reported $9.3 billion or the UK's $4.5 billion.
And this is but the source material consistently says China is closing the gap fast in terms of the actual capability of their AI models, especially large language models.
And they still lead in the sheer number of AI research papers and patents being filed. So, yeah, the private investment gap is there, but the capability gap seems to be shrinking, and the foundational knowledge is spreading globally.
This whole situation ties into what people are calling techno-nationalism.
Right. Major powers are explicitly linking AI development to national security, economic strategy, even projecting influence globally. You see it in China's big national AI plan. You see it in the U.S. talking about exporting American AI tech to allies to strengthen partnerships.
It signals this era where nations increasingly prioritize growing their own domestic AI industries, controlling critical supply chains, especially semiconductors, and tailoring AI regulations to fit their specific national interests and values.
And if you're a multinational company operating globally, this creates a really complex, potentially tricky environment.
You've got to navigate these increasingly different regulatory systems. You might face pressure, subtle or not, to use local tech providers or align with national policies.
And you're definitely encountering more restrictions on transferring technology, moving data across borders, even collaborating on research internationally. It's less about one single global market now.
And more about navigating several distinct regional ecosystems.
Exactly. And this push for sovereign AI isn't just a US-China thing. It encourages other nations in Europe, the Middle East, Asia, to develop their own strategies, invest in their own capabilities, create their own AI champions.
So it leads to a more diverse global AI landscape, but also maybe a more fragmented one. The idea that, say, Silicon Valley dictates the single global AI standard, that's being actively challenged.
Definitely.
So summarizing the geopolitical dynamic for you, the AI world looks less like one big global market and more like several regional blocks. And these blocks are shaped by national goals, security worries, economic policies.
Which fundamentally affects where AI tech gets developed, how it's regulated, who you can partner with across borders, and how you deploy services globally. Understanding the specific sovereign AI plans and policies in the regions you operate in or want to operate in, that's becoming absolutely essential business intelligence.
Okay, moving to the third major force, and this one is really shaking up the competitive field, the rapid and significant maturation of open source AI.
Yeah, this is a huge disruptor. The prediction, and we're seeing strong evidence for it, is that powerful open-weight models where the underlying code and trained parameters are publicly available are really poised to become the standard for a whole range of AI tasks.
This isn't just a technical tweak. It feels like a fundamental shift in how AI gets built, shared, and used.
Absolutely. Open source AI isn't just for academics or hobbyists anymore. These models are increasingly matching and sometimes even beating proprietary systems on key tests and real-world jobs.
And crucially, often at a much lower cost and with way more flexibility for users.
Which directly challenges the dominance of those big, closed, proprietary models that got all the headlines and investment early on in the generative AI boom.
You see major tech players actively driving this. Meta, obviously, with their Llama models. Llama 4 is expected later this year, apparently aiming for hundreds of languages.
They're leading the charge. But also Alibaba with their Qwen models, Baidu with Ernie in China, and Mistral AI, the European challenger, they're all investing heavily in open-weight models.
Their strategy seems to be about democratizing AI, right? Making it cheaper, easier for developers and businesses to get started, and ultimately driving widespread use, building big ecosystems around their models.
Exactly. Lower the barriers, get it into more hands.
This creates a really interesting strategic choice for businesses wanting to use AI. It challenges that old walled garden model where you're locked into one vendor's API.
Open source gives you more choice, more control, and the ability to really tailor models for your specific needs. The decision isn't just build versus buy anymore. It's build versus buy versus adapt. And adapt often means starting with an open source foundation.
But, like always, there are trade-offs, right? Open source sounds great, lower cost, no lock-in, customize anything.
But you generally need more technical know-how inside your own company to actually deploy it, maintain it, manage it, and govern it properly compared to proprietary models.
Proprietary solutions, while, yeah, often pricier and less flexible, usually come with ease of use, support teams, and maybe some built-in compliance features or guarantees, like service-level agreements.
It's a balance, cost versus control versus the internal skills you have or need to build.
And the source material consistently points out that most organizations aren't just picking one side. They're heading towards hybrid approaches.
That seems to be the smart play. Strategically using both open source and proprietary tools depending on the specific job and the business need.
So what this open source maturation means for you is that powerful AI is getting democratized. You have way more capable options now than ever before. That's incredibly exciting for innovation.
But it absolutely demands a clearer strategy inside your organization. How do you choose? How do you deploy? How do you manage these open models responsibly and securely, maybe alongside proprietary ones you also use? Ignoring open source just isn't really an option anymore if you want to stay competitive.
And speaking of managing things responsibly, that leads perfectly into our fourth macro trend, navigating the global regulatory maze around AI. It's evolving fast, getting more complex, and by mid-2025, it's not just talk anymore. It has real teeth. Real deadlines.
Oh, definitely. And it's becoming a major factor for anyone deploying AI. Different places are taking very different approaches, sometimes even conflicting ones.
Like the EU AI Act. That's moving forward quickly, setting up this comprehensive risk-based system. And it has key compliance deadlines hitting right now in 2025, especially for anything deemed high-risk AI.
It's seen as a global benchmark, really, for this kind of broad AI regulation.
Meanwhile, in the U.S., you had that shift early in 2025. The new administration signaling maybe a more deregulatory federal stance, potentially trying to limit what states can do.
But the states haven't slowed down at all. They are still very active, passing laws on data privacy, algorithmic bias, deepfakes, AI in hiring. It's creating this patchwork quilt of rules across the country, even if federal policy shifted.
Then you look at China, they've brought in mandatory labeling for AI-generated content, which is a big move for controlling information, and that takes full effect in September 2025.
And the UK is sticking to its more flexible, principles-based approach, using existing regulators rather than one big new AI law, trying to balance innovation and oversight differently.
This global flurry of regulation, it's a direct reaction to the increasing number of AI screw-ups and perceived risks we're seeing, isn't it?
Absolutely. Privacy breaches, biased algorithms leading to unfair results, the explosion of sophisticated disinformation using AI tools and security holes. AI has shot up the list of top-tier business risks.
We're talking serious legal trouble, big fines, and maybe worst of all, major damage to your reputation.
And the big challenge for companies operating internationally is that there's no global standard. The EU is focused on fundamental rights and safety. The U.S. federal government seems to be prioritizing innovation and competition, those states vary wildly. China is focused on stability and information control.
So there's no single, easy, one-size-fits-all playbook for AI governance that works everywhere.
Which is a huge strategic and operational headache. Businesses using AI, especially across borders, need internal governance frameworks that are agile, adaptive.
You need systems to know where you're using AI, assess the risks involved in each place, and adjust your controls and compliance steps to meet those specific local rules and evolving risks.
Investing proactively in good AI governance, really mapping out your AI inventory, doing thorough risk assessments, setting clear internal policies. It's not optional anymore, it's essential.
It's not just about avoiding fines, right? It can actually be a competitive advantage. If people trust you're using AI responsibly, that builds goodwill, stronger customer relationships.
Exactly. Being seen as a responsible AI player can differentiate you.
So, boiling down the regulatory trend for you, AI regulation isn't some far-off future issue. It's here, now, with immediate compliance demands in different places. Ignoring it, huge risk. But tackling it proactively, building strong governance, that can actually help you navigate the maze and build trust.
So those four trends, the ROI pressure, the sovereign AI race, the open source surge, and the regulatory maze, they really set the stage. They're the big currents shaping the AI ocean in mid-2025.
Okay, that gives us the big picture forces. Now let's zoom in on the players themselves, the competitive landscape. If the AI market is like a dynamic chessboard right now, constantly shifting, who's making the big moves, who's trading queens, who's building up their pawns?
Good way to put it. We can think about it in two acts, maybe. The established titans and then the disruptive challengers.
Perfect. Act 1. The titans. These are the giants who kind of dominated the early generative AI conversation. First up, OpenAI.
Right. By mid-2025, they seem laser-focused on transforming ChatGPT, moving it beyond just a chatbot into something much bigger, the super assistant concept.
Positioning it as the central place you go for. Well, almost anything digital. Potentially even taking on Google search as how we find information and get things done online.
That seems to be the vision, yeah.
Yeah.
Reports suggest they're building their own search index capabilities. That would be a massive strategic move. Their monetization strategy seems phased focus on getting everyone using it deeply first, build that habit, then figure out broader revenue streams later, beyond just subscriptions and API access.
They certainly built a huge user base incredibly fast, and their valuation is enormous.
Right.
But you can feel the pressure, can't you?
Oh, yeah. They constantly need to show new breakthrough innovation, something that keeps them clearly ahead, and they have to justify their premium pricing and closed box approach when those open source models we talked about are getting so good and often much cheaper.
Okay, Titan number 2. Google, primarily through Google DeepMind after they merged their AI divisions.
Their focus feels very much centered on talent attracting and keeping the best AI minds, and then really driving synergy between their cutting-edge research and getting it into Google's massive products.
They're balancing pushing the absolute frontiers of science with building AI products that are scalable, safe, and commercially viable.
You see that in their acquisitions too, targeting expertise in advanced AGI concepts, biomedical AI, building on AlphaFold success, bringing in diverse talent. A key strategy is embedding their research directly into things people use, like the Gemini app ecosystem. They want hundreds of millions of users there, clearly aiming to rival ChatGPT's reach.
And they have these flagship projects, the multimodal Gemini models, the incredible AlphaFold 3 predicting molecular interactions, which is huge for drug discovery.
Genie 2 creating 3D models from images, Project Astra, as their vision for a future multimodal assistant. They're also putting a lot of public emphasis on responsible AI development and navigating all that regulation.
Then there's Microsoft. They are just pouring staggering amounts of money into AI infrastructure.
Colossal investments. Reports say over $80 billion in capital spending for fiscal year 2025, mostly on data centers and specialized AI hardware.
Their big vision seems to be this open agentic web, where AI agents can work autonomously, cooperatively across different apps and services, enabling totally new ways of working.
You see them trying to reimagine software development with GitHub Copilot, evolving from just code help to more of an agent partner for developers. They're also big on global AI skilling programs and strategically exporting U.S. AI tech through partnerships.
Their key offerings, Azure AI Foundry is a big one, that platform for building and running AI, hosting third-party models, including open source ones, GitHub Copilot, M365 Copilot, which is apparently used by something like 70% of Fortune 500s now.
Microsoft Discovery for Science, and they've made key strategic partnerships, like that deep one with Mistral AI.
Okay, final titan in this group, Anthropic.
Their focus is quite distinct. It's really centered on building safer, more steerable, more reliable large AI systems. That's the whole philosophy behind their Claude models, like the recent Claude 3.5 sonnet.
They're also very actively engaging with governments, especially on national security issues related to advanced AI, and pushing for responsible AI governance rules.
They're pretty open about expecting major AI breakthroughs in the next, say, 2 to 4 years, and they're concerned about the potential security risks, things like AI enabling biological weapons development or super advanced cyber attacks.
Strategically, they're partnering with big cloud providers like Google Cloud to get Claude into enterprises via platforms like Vertex AI. They're positioning Claude for business success based on its reasoning skills and those built-in safety features.
Okay, so those are the established giants. Now, Act 2, the challengers. These are the players really shaking things up, often using open source, focusing on efficiency or different business models.
Leading the open source pack, Meta.
Definitely. With the Llama family, Llama 4 coming soon, aiming for massive language support. Their whole strategy is explicit. Democratize AI. Make powerful models accessible, affordable, user-controlled, directly challenging the proprietary guys.
And they're backing it with huge infrastructure spending too, right? Like $65 billion planned for 2025.
Massive investment. But interestingly, it doesn't seem tied to a direct plan to make money from Llama itself. It's more about building the foundational platform, the ecosystem, for others to build on top of.
Their value proposition is low cost per token, high performance, impressive scalability. They showed models running on a single consumer graphics card.
Multilingual support, big context windows, powerful vision AI tools, they're hitting all those points.
Then there's Alibaba, a major global player, especially in Asia. Their Qwen models come in all flavors, commercial and open source, through their Model Studio platform.
And that Qwen 3 release back in April 2025 was really notable for how they did it. Very strategically focused on the developer ecosystem right from the start.
Offering a whole range of model sizes, from tiny ones for edge devices up to big ones, including these mixture of experts versions, highlighting advanced reasoning like hybrid thinking for step-by-step problem solving.
And critically, making sure it worked out of the box with all the popular tools developers actually use, Hugging Face Transformers, Llama.cpp, Llama, LM Studio, special optimization for Apple Silicon with LXLM, VLLM for fast server deployment. That day one usability was key.
Next challenger, Baidu. Absolutely dominant within China. Their AI vision is built around their ERNIE models.
They've been iterating fast. ERNIE 4.5, which is multimodal, ERNIE X1 for reasoning. Then these turbo versions came out offering much lower prices. ERNIE 5.0 is apparently planned for later this year, promising even better multimodal skills.
Their strategy links closely to their AI cloud services and their Apollo Go autonomous taxi business, which is expanding fast in China.
And their AI work is very much aligned with China's national strategy. ERNIE gets huge use within China. Reports mention over 1.5 billion API calls per day. But they do face fierce competition from other Chinese tech firms also pouring money into AI.
Okay, final challenger to highlight. Mistral AI, Paris-based, emerged super fast as Europe's leading AI player, making waves globally even though they're much smaller than the US or Chinese giants.
Their focus has been laser sharp on open source, highly efficient models. They've pulled off impressive funding rounds, hit a huge valuation, $6.2 billion by mid-2024, and they talk about maybe going public.
They have that key partnership with Microsoft, giving them access to compute power and distribution.
Their core value: high-performance models that are smaller, leaner, cheaper to run than many alternatives, They offer models tuned for coding, a ChatGPT competitor called LeChat, and powerful instruction-following models known for accuracy, function calling, code generation, and handling long documents.
Okay, so looking at this whole chessboard in mid-2025, who's really gaining ground and who's maybe feeling the squeeze?
Well, collectively, you'd have to say the open source providers are major winners in terms of influence and adoption. They're improving capabilities, the cost advantages, the flexibility, the growing ecosystems around them. It's a powerful combination that's challenging the incumbents.
Among the titans, Microsoft looks incredibly strong. They're leveraging their cloud dominance, their deep enterprise ties, that Mistral partnership, their whole platform strategy. It's working.
Google is also gaining momentum, really effectively translating their amazing R&D into products people use and showing unique strengths, especially in scientific AI.
And who's feeling the heat? Well, even leaders like OpenAI are definitely under more pressure. They need to keep innovating fast to stay clearly ahead of those increasingly good, much cheaper open source options, and they have to keep justifying their price points.
Baidu, while huge in China, faces relentless and nimble domestic rivals biting at their heels.
The reasons for these shifts seem tied to the macro trends we discussed, right?
Absolutely. Core LLM features are getting commoditized. Just having a big model isn't enough anymore. The cost-performance math is crucial for businesses focused on ROI, and that often favors efficient open source or smaller models.
Plus, businesses increasingly want more customization and control, which open source naturally offers. And the strength of the whole ecosystem around a model, the tools, the support that's accelerating adoption.
It means the main battleground is shifting. It's less about just who has the highest score on some benchmark.
And more about the strength of the whole platform and ecosystem around the model. Things like Azure AI Foundry, Google's Vertex AI, Alibaba's Model Studio. The value is increasingly in the tools, the infrastructure, the security, the management, that whole last mile of making AI actually work reliably in a business.
So if we had to guess the next 3 moves for some key players based on what they're saying and doing.
Speculate away. Grounded speculation, of course.
Okay. You could see OpenAI pushing hard to make that super assistant vision real, integrating deeper into workflows, maybe really rolling out that search challenger. Meta will almost certainly double down on building out the Llama ecosystem, making it even easier for others to build on their open models.
And Microsoft.
Probably accelerate that agentic web vision, making it easier and safer to build, deploy, and manage those complex autonomous AI agents operating across their whole software universe.
Fascinating. It's definitely not a static picture out there. The players are constantly adjusting.
Not at all. And their strategies are fueled by and connected to what's happening right at the cutting edge of the technology itself.
Which is our next stop. Let's dive deep into the frontier tech, the stuff that's really pushing the boundaries of what AI can actually do right now.
First up, a concept that sounds almost sci-fi but is becoming real. AI designing AI.
Okay, AI designing AI. What does that actually mean? Is it the machines taking over or something more practical?
Definitely more practical for now. The long-term implications are, well, pretty profound. Put simply, it's about AI systems that can autonomously discover, design, and optimize other AI models, algorithms, or even complex software and hardware systems with minimal human input.
Oh.
Often using techniques like evolutionary algorithms or reinforcement learning. The AI basically generates possible solutions, tests them against some goal or metric, learns from the results, and then refines or evolves the solutions iteratively.
So the AI is actively involved in its own improvement or in improving other systems humans built.
Exactly. A key example coming out of recent research is DeepMind's AlphaVolve. It apparently uses large language models like Gemini to generate and improve computer programs or algorithms based on some evaluation criteria set by a human or another system. The AI isn't just running code, it's figuring out how to write better code or design a better algorithm to achieve a goal.
And this is where it gets really interesting because recent breakthroughs, like in Q2 2025, show this moving beyond just research labs into having real-world, large-scale impact. AlphaVolve is reportedly delivering significant results inside Google's own massive operations.
That's the key development. AlphaVolve was apparently used to develop a more efficient heuristic, basically, a smarter rule or algorithm for Google's Borg system. Borg is the incredibly complex software that manages how computing jobs get scheduled and resources get allocated across Google's global network of data centers.
And the result?
The AI design solution reportedly recovered a staggering 0.7% of Google's entire worldwide compute capacity.
Okay, 0.7% sounds small, but at Google's scale, Millions of servers.
Yeah.
That's an absolutely enormous amount of processing power.
It's huge.
Yeah.
Equivalent to the entire infrastructure of many large companies. Freed up, ready to run other services, train more AI models, or just save massive amounts on the power bill. It translates directly into big financial value and more capacity for innovation.
Wow. And it's not just high-level system management.
No, AlphaVolve also showed it could optimize low-level stuff, like specific operations used in training AI models. For instance, finding better ways to do kernel tiling, which sped up certain training tasks by 23%, or optimizing flash attention operations, getting a 32% speed up. These are big accelerations in the fundamental mechanics of AI development.
This is incredibly powerful. It shows designing AI isn't just a theory anymore. It's becoming a tool for hyper-optimization at industrial scale, directly impacting the efficiency of the world's biggest tech systems.
So let's translate this frontier for executives, for business value. What does it mean for you? It enables hyper-optimization of really complex business processes. Think logistics, supply chains, resource planning, maybe finding efficiencies humans or traditional algorithms just couldn't spot.
It could dramatically speed up R&D. We'll talk about drug discovery later, but also material science, optimizing software engineering.
And maybe less obviously, the new algorithms or optimized processes discovered by this kind of AI, that could be valuable, defensible intellectual property. The AI isn't just using tools, it's inventing better tools.
So the core business value here is about cutting operating costs at scale, getting new products or improvements out faster, and gaining this unique sort of meta-level competitive edge. You're not just using AI, you're using AI to get better at everything you do with AI. That creates a compounding effect that's hard to beat.
Exactly, a powerful frontier.
Okay, our second frontier builds on that open source trend we talked about earlier. It's the idea of the open source revolution maturing into what some are calling open source 2.0.
Right. This phase isn't just about model weights being available. It's about the widespread availability of powerful, efficient, and increasingly specialized open source models, where the code, the weights, everything is public. Free to use, modify, deploy.
And the key difference now in this maturation phase.
They're not just experiments anymore. They are seriously rivaling and sometimes beating proprietary systems on performance in specific tasks. They offer real alternatives with more transparency, more control, and often way better cost effectiveness.
We're seeing this across the board, right? Like major players like Alibaba, DeepSeek, Baidu, Meta, Mistral are all releasing high-quality open models. And there's this vibrant global community building tools and expertise around them. The whole ecosystem is just flourishing.
And the example that really highlights this maturation, this open source 2.0 idea, was that Alibaba Qwen 3 release back in April. It wasn't just about the model performance itself, which was good. It was the strategic developer-first ecosystem rollout from day one.
They put out models across the whole spectrum of sizes, tiny to huge, including those mixture of experts types. They talked up advanced reasoning features like hybrid thinking, getting the model to show its work, basically.
But the really significant thing, the marker of open source 2.0, they made sure it worked immediately with a ton of the most popular LLM frameworks and developer tools.
Right, like Hugging Face transformers, Llama.cpp for running locally, Llama, LM Studio, optimization for Apple chips via MLX-LM, VLLM for fast server deployment. The list went on.
That level of instant usability right out of the box, that sets a new bar for open source releases. It wasn't just, here are the weights, good luck. It was, here's a solution you can integrate today.
And the fact that their smaller Qwen 3 models were matching or beating older, much larger models just underlines how fast efficiency is improving in the open source world. It makes them direct, compelling alternatives to proprietary systems, both in power and ease of use for developers.
So from a business perspective, the takeaways here are huge. Open source 2.0 means less vendor lock-in, potentially much lower operating costs compared to pricey APIs.
It fuels faster, cheaper innovation. You can prototype quickly, try niche ideas that wouldn't justify a big proprietary model license.
It strongly enables those sovereign AI efforts, or just better data control for any company. You can run these models on your own servers in your private cloud, keeping sensitive data completely in-house. And you get deep customization by fine-tuning on your own unique data.
The caveats still apply, though.
Absolutely. You still generally need more in-house tech expertise to deploy, manage, and fine-tune open source effectively compared to a managed proprietary service. Security, making sure the model wasn't trained on stuff it shouldn't have been, ongoing upkeep that all needs careful handling.
And this points to that critical shift we mentioned. As open source models get better and basic AI features commoditize, the real competitive value moves to the last mile.
Exactly. How easily can you integrate this model, customize it, manage it securely, support it within your existing tech stack and workflows? Qwen 3's focus on the ecosystem is the perfect example. The value isn't just the raw model, it's how easy they make it for you to actually use it and get value from it in a production setting.
Okay, third frontier. Advanced AI compute and inference-time processing. Sounds technical, but the core idea is about making AI models smarter without just training bigger ones, right?
That's the essence of it. This frontier involves techniques to boost a model's accuracy, reasoning, and overall capability while it's actually processing a request during inference without necessarily needing a full, costly retraining cycle.
It's like making the model think longer or think better on the spot.
Precisely. Things like chain-of-thought reasoning fall here, prompting the model to break down a problem into steps before giving the final answer. It allows for multiple internal reasoning passes, or test time scaling. It's a strategic shift away from just throwing more data and compute at training bigger models.
And there's a really novel concept that emerged recently around May 2025, groupthink.
Yeah, this one's fascinating. The idea is to treat a single large language model not as one entity, but as multiple concurrent reasoning agents or thinkers working together internally.
Inside the same model, like a committee meeting in its head.
Kind of,
Yeah.
but maybe more like different cognitive streams operating simultaneously, sharing progress and intermediate results, maybe even at the level of individual tokens being generated, all collaborating on a single complex query.
Wild. And there's actual evidence this works.
Early days, but yes. The Q2 2025 breakthrough was initial experimental validation. Researchers found that even existing open-source LLMs, if you prompt and manage them the right way, start showing these preliminary forms of collaborative behavior among internal thinkers.
And the key finding?
This token-level collaboration seems to improve reasoning accuracy on complex problems and might even be faster, lower latency than traditional approaches, where you have separate AI agents passing results back and forth sequentially.
The significance could be huge. It might change how we even think about LLMs, less as single minds, more as sophisticated collectives.
It could substantially boost reasoning power and efficiency for tough, multi-step problems. And it seems promising for making better use of compute, maybe enabling more complex AI on edge devices with limited power. It connects to ideas like Qwen 3's hybrid thinking or DeepSeek R1's focus on step-by-step reasoning, too.
So let's bring this back to business value, the executive takeaway. What does this mean for you? It means potentially getting way more mileage out of the AI models you've already invested in.
Right. Using these techniques might let you improve performance on complex tasks without needing that massive expense and effort of retraining or upgrading to a much bigger, costlier model.
It could significantly improve the quality, the coherence, the trustworthiness of what your AI applications produce. Better reasoning, better error checking during inference that's crucial for business adoption, where reliability is everything.
And maybe most importantly, it enables AI to tackle much more complex reasoning tasks. This is vital for making truly autonomous agentic AI systems practical. Systems that need to analyze situations, weigh options, and make solid decisions in real time.
Plus, that potential for enhanced efficiency could make complex AI feasible on lower power devices or in situations needing super fast responses.
And this frontier, sophisticated inference-time processing, it ties directly into that whole vision of agentic AI.
The idea of AI systems that can understand a goal, plan steps, execute actions using different tools, and learn from feedback.
Exactly. Those systems need powerful, on-the-fly reasoning. Techniques like advanced chain of thought, tree of thoughts, maybe this groupthink idea, they provide the cognitive horsepower for agents to analyze problems, explore solutions, anticipate outcomes, and make robust decisions in dynamic situations. This frontier is absolutely crucial for moving agentic AI from cool demos to useful, deployable business tools.
So these three frontiers, AI designing AI, open source 2.0 making powerful tools easily accessible, and advanced inference time compute making models smarter on the fly, that's the absolute cutting edge right now, pushing the envelope of what's possible.
And these advances, driven by those macro forces and reshaping the competitive map, are already having massive impacts on specific industries.
Let's focus on one that's right in the eye of the storm in mid-2025, healthcare transformation.
Yeah, arguably one of the sectors most profoundly disrupted by AI right now. It's touching almost everything: basic research, drug discovery, diagnostics, patient care, even how hospitals run.
And it's creating clear winners and losers, isn't it? Companies, hospitals that are deeply integrating AI are gaining real advantages. Those slow to adapt, stuck with old systems, they risk falling seriously behind. It's becoming a real AI divide in healthcare.
Let's look at specifics. Accelerated drug discovery is a huge one. AI is turning this incredibly long, expensive, failure-prone process on its head.
We're seeing reports of dramatic cuts in preclinical timelines the stage before human trials, maybe from 5 years down to just 12 or 18 months in some cases.
And big cost savings too, 25–50% in preclinical, maybe up to 40% overall project cost reduction potential.
The projection is pretty striking. By the end of this year, 2025, maybe 30% of all new drugs starting development will have been discovered or significantly helped along by AI.
Foundational models like Google DeepMind's AlphaFold 3, predicting how all life's molecules interact. Absolutely critical here. And we see those AI designing AI principles in action. Tools like Recursion's Boltz 2 platform predicting how well drug molecules bind to targets.
Doing it nearly as accurately as lab tests, but maybe 1,000 times faster, that just revolutionizes early drug screening.
Then moving beyond the lab, AI is massively enhancing diagnostics and enabling personalized medicine, improving the speed and accuracy of reading medical images, finding tumors, detecting strokes faster.
We've seen a huge jump in FDA approvals for AI-enabled medical devices. They're becoming standard tools in radiology, pathology.
And this relies heavily on that advanced AI compute we talked about,
Yeah.
and increasingly on multimodal AI that can pull together diverse data images, health records, genetics, lab results for a much richer picture.
AI is also streamlining clinical trials, which are a huge bottleneck and cost center, helping with patient recruitment, a major reason trials fail, improving retention, even predicting trial outcomes using digital twins.
And making decentralized clinical trials more feasible. Plus, just basic operational efficiency in hospitals, optimizing scheduling, predicting patient needs. There's that NVIDIA healthcare collaboration using physical AI and simulation for autonomous X-ray and ultrasound tasks, trying to automate things, ease staffing pressures.
What about open source in healthcare? We mentioned it earlier.
Potential, yes. That Harvard Med study showed an open source LLM matching a proprietary one on complex cases. If, and it's a big if, it can be properly validated, secured, and proven compliant with strict rules like HIVAIA or GDPR.
It could democratize access to advanced tools for smaller hospitals or clinics that can't afford the big proprietary systems.
But the hurdles are significant. Data security, model reliability, bias checks, regulatory sign-off. It requires immense care and investment.
Let's zoom in on a specific, really compelling example. Genentech, the big biotech player, part of Roche. How are they using generative AI?
They are embedding it deeply into their R&D, way beyond just pilots. A key example is their GRED research agent. It's built on AWS using Anthropic's Claude 3.5 Sonnet model via Amazon Bedrock agents.
And what does this agent do?
It automates the incredibly time-consuming job of digging through scientific papers, internal experimental data, public databases, tasks that used to take scientists weeks, like validating potential biomarkers for a disease.
Can now reportedly be done by the AI agent in minutes.
The impact. Genentech expects to save over 43,000 hours of scientist time per year just with this one agent. That's freeing up highly skilled people to focus on actual science, designing experiments, interpreting results, not just information retrieval.
And it's part of a bigger strategy, this lab-in-a-loop idea.
Exactly. The AI doesn't just fetch data, it helps guide the design of the next experiment based on what it found. Then the results of that experiment feed back into the AI, refining its understanding, guiding the next experiment.
It's this continuous feedback cycle, accelerating discovery, exploring possibilities faster, optimizing drug candidates more effectively. A real-world application of those AI designing AI principles.
The key for Genentech is tackling the sheer complexity of biology, genes, proteins, cells interacting. Their edge isn't just having AI, it's combining their deep science knowledge, their unique internal data, and customized AI tailored to their specific biological questions. That creates a powerful competitive advantage.
These kinds of transformative stories, plus the obvious high stakes when AI touches patient health. It raises a big question. Given the rise in FDA approvals for AI medical tools, should regulators like the FDA start certifying the AI models themselves, like they certify drugs?
That's a really hot debate right now. On one hand, the potential impact on safety is huge. Certification could build public trust, ensure models meet tough standards for accuracy, reliability, fairness before they're used in critical situations.
Makes sense. But AI models aren't like pills, right? Especially ones that keep learning or get updated frequently. They're not static. How do you certify a moving target?
Exactly. How do you ensure an update doesn't break something or introduce bias later after certification? It highlights how traditional regulation struggles with these dynamic learning systems.
It's a clear example of AI challenging existing frameworks. And it's not just theoretical. Policymakers, developers, doctors are actively grappling with it. Okay, let's shift from the tech in specific industries to the people and the money. What's happening with talent? And where's the investment really going beyond just the huge players?
Well, the demand for AI talent is still incredibly high, no surprise there. But the skills needed are changing super fast.
How fast?
One report suggested skills in AI-exposed jobs are evolving 66% faster than in other jobs. It's a major shift away from just general AI awareness towards really specialized system-level expertise.
So based on everything we've discussed, what are the hottest roles right now, mid-2025?
Huge demand for AI system optimizers and efficiency experts. People who can take any model, proprietary or open, and tune it perfectly for performance, cost, power use, maybe even specific hardware like ASICs or GPUs.
Given things like AlphaVolve, those evolutionary algorithm specialists, or AI designing AI experts, that's becoming a niche but extremely valuable skill set, building and managing those self-improving systems.
With the open source explosion, open source integration and customization experts are vital. Engineers who know how to pick the right open model, integrate it, fine-tune it, deploy it securely in a complex business environment. Knowing the specific frameworks and tools is key.
And as that agentic AI vision gets closer, agentic AI engineers or orchestration specialists are emerging, designing and managing systems where multiple AI agents work together. Knowing frameworks like semantic kernel, autogen, MCP becomes important.
The complex regulatory and risk picture means AI governance, ethics, and privacy specialists are in high demand. Navigating rules, managing risks, spotting bias, implementing privacy tech. You're seeing job titles like AI governance lead pop up more and more.
Core data scientists and ML engineers are still crucial, obviously, but their jobs are evolving fast too. They need to know generative AI, MLOps for managing lots of different models, how to work in these hybrid environments, mixing open and closed source.
And it's not just the specialists, right? There's also this rise of the generalist engineer with AI acumen.
Yeah, regular software engineers who are becoming AI literate, using tools like GitHub Copilot to quickly build AI features into products, even without a deep ML background.
This creates this sort of bifurcated need. You need those elite specialists, and you need a broad base of AI-savvy generalists across your engineering teams. It requires a two-pronged talent strategy.
Recruit the specialist, definitely, but also invest heavily in upskilling and reskilling your current workforce so they can leverage these new tools and integrate AI effectively. Some companies, like Microsoft, are really pushing this idea.
And this ties directly into how businesses should think about investing in AI now. It's not just about throwing money at the latest shiny model. It's strategically balancing investment in foundational capabilities with targeted bets on high ROI applications and the infrastructure to actually run it all.
The smartest path for many organizations seems to be explicitly adopting a hybrid model approach for their AI stack.
Makes sense. Use proprietary models for those critical customer-facing things where you absolutely need the SLAs, the support, vendor accountability, built-in compliance, especially in regulated sectors like finance or healthcare.
But then strategically use open source for R&D, internal tools, specific niche problems where you need flexibility, deep customization, maybe you need total control over your data for sovereignty or privacy reasons, and where cost is a major factor.
It requires more internal skill, yes, but offers huge strategic upsides.
And regardless of which models you choose, prioritizing the right infrastructure for advanced inference and efficiency is critical if you want to use AI at scale.
That means investing in or getting access to optimized hardware, custom silicon like ASICs for specific jobs, specialized chips for edge AI.
And managing your compute efficiently is non-negotiable. Optimizing data centers for memory, power, getting the most inference speed per watt. That's crucial, especially as these agentic AI systems might increase the load during inference time. Investing in platforms that support those advanced inference techniques we discussed, chain of thought, maybe even groupthink down the line, is key to getting the most value.
Strengthening data governance and quality. Absolutely non-negotiable. Full stop.
As AI gets deeper into everything and regulation tightens, you must have robust frameworks, solid quality checks, clear tracking of where your data came from. It's essential for compliance, building trust, managing risk. Remember those past incidents where models messed up due to questionable training data? High-quality, well-governed data is the absolute foundation.
Investing in good AI platforms and mature MLOps practices is also essential. Whether you buy a commercial platform or build your own, you need these tools and processes to manage the entire life cycle of potentially many different AI models: development, deployment, monitoring, updates, governance, handling both proprietary and open source smoothly.
And finally, always, do a thorough total cost of ownership analysis, TCO.
Look beyond the sticker price or the download button. Factor in ongoing maintenance, support costs, upgrades, the potentially escalating compute costs as usage grows, compliance costs in this changing regulatory world, and critically, the cost of hiring or keeping that specialized AI talent you need.
Yeah, an open source model might have zero license fee, but the internal costs to run and manage it effectively could be substantial.
The best investment strategy isn't one size fits all. It's a portfolio approach, tailored to specific business goals, use cases, risk levels, potential value, and managing that requires strong internal leadership, both technical and strategic.
This isn't just theory, it's how the smart companies are actually building and scaling AI right now.
Okay, to wrap things up, how about a quick rapid-fire news ticker? Just a few recent headlines that really underscore some of these trends. Quick snippets.
Sounds good. Hit me. First one.
A report out from one of the leading AI labs detailing new steps they're taking to clamp down on misuse and protect their intellectual property. Things like stricter API access rules, better ways to trace model outputs back to their origin, really reflects those ongoing security and IP risks we talked about.
Okay, next.
Legislative chatter in the U.S. Congress. A proposed provision tucked into a budget bill that could potentially put a multi-year pause or limit on states passing their own AI laws. Could really reshape that fragmented U.S. policy landscape, maybe centralize things more, but likely controversial.
Interesting. And one more.
Buzz around the rollout of the big EU AI Act. While it's moving forward, there are discussions about potential complexities or maybe phased approaches for meeting some key deadlines coming up soon, especially around clearly labeling AI-generated content and getting those high-risk systems officially assessed. Highlights the real-world challenges of putting complex regulations into practice.
Quick hits, yeah, but they nail the themes. AI risks are real and being actively managed. Regulation is happening, but facing shifts and practical hurdles, and the whole landscape just keeps moving incredibly fast.
Exactly. Brings us right back around.
Back to that opening question for you, listening. In the storm of change, these powerful forces, shifting players, amazing tech industry shakeups, are we really steering this revolution, making conscious choices about its direction, or are we mostly passengers, just reacting?
We've covered a lot. Those big macro forces. The relentless push for ROI driving efficiency, the geopolitical scramble for sovereign AI fragmenting the market, the disruptive rise of open source democratizing power, and that complex, growing regulatory web demanding smart governance.
We looked at the competitive map, how the titans and challengers are battling it out, shifting focus from just raw model power to the strength of platforms, ecosystems, and real-world applications.
And we dove into the cutting edge. AI designing AI, starting to optimize systems at scale, open source 2.0 becoming a production-ready reality, advanced inference-time compute, making models smarter on the fly, powering that agentic AI vision.
We saw the profound impact in sectors like healthcare, with companies like Genentech showing how combining AI with deep domain knowledge creates a serious competitive edge, while others risk being left behind.
And we talked about the human and capital side, the fast-changing talent needs, the shift to hybrid model strategies, the critical need for infrastructure investment, and the absolute necessity of solid data governance and risk management covering security, bias, privacy, and reputation.
Navigating all this effectively, whether you're leading a business, building tech, or just trying to understand the world, it takes more than just awareness. It demands agility, constant learning, and figuring out your own clear, adaptable strategy.
So here's a concrete challenge for you this week. Based on all this, identify just one thing, a workflow, a process, a task you deal with in your daily life, work or personal, that could potentially be improved, changed, or done differently using AI, given the capabilities we've explored.
Just one. Think about something repetitive or complex or that needs analysis or could just be faster or better.
It's about starting to deliberately look at your world through that AI lens, finding those specific leverage points in your own context.
And as you mull over that one workflow, here's one last, maybe slightly more provocative thought to leave you with. We talked about AlphaVolve, how AI is now helping design better AI and optimizing complex systems like data centers, freeing up huge resources.
If AI can optimize the very tools and infrastructure that run AI itself, does that create a whole new kind of compounding advantage?
Will the ability for organizations to build and use these meta AI systems, the AI designing AI, the AI optimizing AI, become the ultimate differentiator in the coming years, potentially creating an even wider gap between those who can harness this recursive improvement and those who can't?
Something to keep in the back of your mind as you navigate this landscape.
We are still, relatively speaking, in the early days of this AI revolution. Understanding these fundamental forces, the cutting-edge possibilities, it's absolutely key to steering your own course and making informed choices about how this technology shapes your work and your life.
We'd love to hear your thoughts. What questions do you have? Or what workflow did you identify? Feel free to share them with us. Maybe send a voice memo or a message to the show.
Until the next deep dive.
Keep learning.